The Chengdu J-20 Mighty Dragon represents one of the most significant milestones in modern military aviation, symbolizing China's rise as a leading aerospace power and its determination to compete at the highest technological level. As a fifth-generation stealth fighter, the J-20 was developed to secure air superiority, project power over long distances, and operate effectively in highly contested environments. From its earliest conceptual stages to its current operational deployment, the aircraft reflects decades of strategic planning, technological ambition, and sustained investment in research and development. Its emergence has reshaped global discussions about air combat, deterrence, and the future balance of power in the skies. The origins of the J-20 can be traced back to the late 20th century, when Chinese military planners recognized that future conflicts would demand more than numerical strength. Advanced sensors, information dominance, stealth, and long-range precision would define success. At that time, China's Air Force relied largely on upgraded versions of older aircraft designs, many influenced by Soviet-era technology. While effective within certain limits, these platforms were increasingly vulnerable to modern air defense systems and advanced enemy fighters. The decision to pursue a fifth-generation fighter was therefore both a strategic necessity and a statement of intent, signaling that China aimed to close the technological gap with the world's most advanced air forces. From the outset, the J-20 program was designed with a clear emphasis on stealth. The aircraft's shape, surface alignment, and internal weapon bays were all optimized to reduce radar cross-section. Sharp angles, smooth blending of the fuselage and wings, and careful placement of inlets and exhausts help minimize radar reflections. Extensive use of composite materials not only reduces weight but also contributes to lower observability. These design choices allow the J-20 to penetrate defended airspace with a reduced risk of detection, enabling it to engage targets before adversaries are even aware of its presence. One of the most visually distinctive features of the J-20 is its large airframe and forward canards. This configuration has sparked debate among analysts, as canards are sometimes associated with increased radar visibility. However, their inclusion reflects a balance between stealth and aerodynamic performance. The J-20 is a relatively large fighter, optimized for long-range missions, high fuel capacity, and the carriage of powerful sensors and weapons. Its size allows it to operate over vast distances, making it particularly suited for missions involving extended patrols, long-range interception, and strikes against high-value targets deep within contested zones. Engine performance has long been a focal point of discussion surrounding the J-20. Early production models relied on interim power plants that did not fully meet the expectations typically associated with fifth-generation fighters, particularly in terms of supercruise capability and thrust-to-weight ratio. Over time, however, China has made substantial progress in indigenous engine development. Newer variants of the J-20 are equipped with more advanced engines that provide greater thrust, improved efficiency, and enhanced reliability. These improvements translate into better acceleration, higher sustained speeds, and increased operational flexibility, allowing the aircraft to perform a broader range of missions with greater effectiveness. Avionics and sensor integration are central to the J-20's combat effectiveness. The aircraft is equipped with an advanced active electronically scanned array radar capable of tracking multiple targets simultaneously at long ranges. This radar works in conjunction with infrared search and track systems, electronic warfare sensors, and secure data links to create a comprehensive situational awareness picture for the pilot. Rather than relying on a single sensor, the J-20 fuses data from multiple sources, presenting it in a clear and actionable format. This sensor fusion capability enables faster decision-making and enhances the aircraft's ability to operate as part of a larger networked force. The cockpit of the J-20 reflects modern design philosophies focused on reducing pilot workload and maximizing combat effectiveness. Large multifunction displays provide critical information at a glance, while advanced flight control systems assist with aircraft handling and stability. The pilot is not merely flying the aircraft but managing a complex system of sensors, weapons, and communications. Automation plays a key role, allowing the pilot to focus on tactical decisions rather than routine tasks. This human-machine integration is a defining characteristic of fifth-generation fighters and is essential for success in high-intensity, information-rich combat environments. Weapons carriage on the J-20 is primarily internal, preserving its stealth characteristics. The main internal base can house long-range air-to-air missiles designed to engage enemy fighters, bombers, and support aircraft such as tankers and airborne early warning platforms. Smaller side bays are believed to carry short-range missiles for close-in combat. This configuration allows the J-20 to engage a wide range of aerial threats while remaining difficult to detect. When stealth is less critical, the aircraft can potentially carry external stores, increasing its payload and mission versatility at the cost of higher observability. The operational concept behind the J-20 emphasizes beyond visual range combat and information dominance. Rather than relying solely on close-range dogfighting, the aircraft is designed to detect, track, and engage adversaries at long distances. By leveraging stealth and advanced sensors, the J-20 can strike first, reducing the likelihood of being targeted in return. This approach aligns with modern air combat doctrine, which prioritizes early detection, coordinated attacks, and the disruption of enemy command and control systems. In addition to its role as an air superiority fighter, the J-20 is also seen as a strategic asset capable of influencing broader operational outcomes. Its range and payload make it well suited for missions aimed at neutralizing high-value targets, such as enemy reconnaissance aircraft or command nodes. By denying adversaries access to critical information and support assets, the J-20 can shape the battlespace in favor of friendly forces. This capability extends its impact beyond individual engagements, contributing to overall campaign success. Pilot training and doctrine development are crucial components of the J-20 program. Operating a fifth-generation fighter requires a different mindset compared to older aircraft. Pilots must be proficient not only in flying skills but also in systems management, data interpretation, and networked operations. China has invested heavily in advanced simulators and training programs to prepare its pilots for these demands. Realistic training environments allow crews to practice complex scenarios, refine tactics, and build confidence without the risks associated with live combat training. The introduction of the J-20 has had a significant impact on regional and global security dynamics. Its deployment enhances China's ability to project air power and defend its interests across a wide area. Neighboring countries and major powers alike have taken note, adjusting their own force structures and modernization plans in response. The presence of a capable stealth fighter alters calculations related to deterrence, escalation, and crisis management, underscoring the strategic importance of advanced air combat platforms. From an industrial perspective, the J-20 program has driven substantial advancements within China's aerospace sector. Developing a fifth-generation fighter requires expertise in materials science, precision manufacturing, software engineering, and systems integration. The knowledge and experience gained through the J-20 project have strengthened China's domestic industrial base, reducing reliance on foreign technology and fostering innovation across multiple fields. These benefits extend beyond military applications, contributing to broader technological progress and economic development. The J-20 is not a static design but an evolving platform. Continuous upgrades to software, sensors, and weapons ensure that it remains relevant in the face of rapidly advancing threats. As new technologies emerge, such as artificial intelligence and improved unmanned systems, the J-20 is expected to integrate these capabilities into its operational framework. This adaptability is essential for maintaining effectiveness over the aircraft's service life, which is expected to span several decades. One area of particular interest is the potential integration of the J-20 with unmanned aerial vehicles. Concepts involving manned-unmanned teaming envision the fighter acting as a command node, directing drones that perform reconnaissance, electronic warfare, or strike missions. This approach could extend the reach and survivability of the force while reducing risk to human pilots. Such developments align with global trends in military aviation and highlight the forward-looking nature of the J-20 program. Comparisons between the J-20 and other fifth-generation fighters are inevitable. Each aircraft reflects the strategic priorities and operational philosophies of its country of origin. The J-20's emphasis on range, payload, and interception capability distinguishes it from designs that prioritize extreme maneuverability or multi-role flexibility. While debates continue regarding specific performance parameters, there is little doubt that the J-20 represents a credible and sophisticated addition to the global inventory of advanced combat aircraft. Public perception of the J-20 within China has been shaped by its role as a symbol of national achievement. Appearances at air shows and military parades reinforce its status as a flagship of modern Chinese technology. This visibility serves both domestic and international purposes, demonstrating confidence in the nation's industrial capabilities and its ability to defend its interests. The aircraft has become an emblem of modernization, reflecting broader societal narratives about progress and self-reliance. Looking ahead, the J-20 is likely to remain a central component of China's air power strategy. As geopolitical competition intensifies and technological change accelerates, the ability to control the air domain will remain a critical factor in national security. The lessons learned from the J-20's development and operation will inform future programs, shaping the next generation of aircraft and systems. In this sense, the J-20 is both a product of past efforts and a foundation for future innovation. Ultimately, the J-20 Mighty Dragon embodies the convergence of technology, strategy, and ambition. It demonstrates how sustained investment and long-term planning can yield transformative capabilities. More than just a fighter jet, it is a strategic tool designed to operate in complex, high-threat environments and to influence the broader balance of power. As it continues to evolve and integrate new technologies, the J-20 will remain a subject of intense interest and analysis, representing a defining element of modern air warfare and a clear signal of China's place in the aerospace arena.